So the last video we asked this question, can you have a set has a cardinality larger than the natural numbers? So is there a set with cardinality larger than the natural numbers but less than the set of all real numbers? So is there something in between these? So this is a famous question called the Continuum Hypothesis. So we're trying to figure out this continuum question, the Continuum Hypothesis. The answer to this question is it is independent of the axioms of set theory. Okay, now we get to start to delve into some of the weirdest things, hopefully, that you will ever see mathematically. This is the goal of this now, is to help you understand what is mathematics. Many of you have been doing mathematics for your whole life, never really asking, what is mathematics truly? And so we have this weird answer because every single math question that you have ever been asked is either a yes or a no, or you could phrase it in some type of way. Either, think about it logically, either a statement is going to be true or it's going to be false. So this statement, so if we think about phrasing this as a statement, the statement that there is a set with cardinality larger than the natural numbers but less than the real numbers. That is a statement, and we said statements are either true or they're false. But yet the answer is not true or false. The answer is that it is independent of the axiom of set theory. So what that means is that you can't prove that it's true. It's impossible to prove that there is a set that fits this. But yet it's also impossible to disprove. So you can't prove it and you can't disprove it. It is going to be, we don't know. We don't have the mathematics to answer this question, but not that we don't have the mathematics, that we haven't discovered it yet, but mathematics does not have an answer to this question from the way that we have understood mathematics forever. But what does that mean? What does it mean for us to have all of the math that we've understood forever? So remember, what we said was that sets are the foundation of math. We said that we're studying sets because everything we do mathematically can be viewed in terms of sets. Now, there's a lot of things that you're like, I doubt that could be done. Well, yes, it can be done. I guarantee you. You just don't know what that looks like in terms of set theory. It gets really weird. But we said that sets are the foundation of math. But on the other hand, if you recall a while ago, we talked about cardinality. Is that an equivalence relation? We said if it was an equivalence relation, it has to be defined on a set. But remember, if we looked at this idea of the set of all sets, if it was an equivalence relation, it would be on the set of all sets. And what did we say about that? We said that set doesn't make sense. You can't form the set of all sets. And so we call this guy here, we call this Russell's paradox. So this was Bertrand Russell back in, I think it was 1901. Bertrand Russell was like, wait a minute. Your concept of sets that is underlying everything you do mathematically, there's major flaws in it. This willy-nilly approach of saying a set is any collection of elements or any collection of objects, that doesn't make sense because I can't even form a set of it. I can't form a set of all the sets. So Bertrand Russell came up with this idea, and then all of a sudden, mathematics started to crumble. All of a sudden, everyone was like, wait a minute, this is the 1900s. We've been doing mathematics forever, and now you're saying mathematics is starting to contradict itself, that we can't really have mathematics make sense anymore. So then this led to this huge discussion about how do we start to be able to create mathematics from the ground up? How can we have something that we can agree upon and then be able to base every other mathematical result upon that? How could we have this starting point? And so that leads to a huge discussion now about what is mathematics even based upon? All of the math that you've done in your entire life, you've just always been convinced that this works. But it doesn't. There's major flaws in mathematics that we know and we appreciate. So we need to dig deeper and understand, what is mathematics actually based upon? Can we even believe that what we're doing makes sense anymore? Everything is supposed to be logical, right? We have this logical intuition behind us, and everything mathematical we love because it's logical, but yet this is not logical. And this points out, saying that no, not everything all of a sudden becomes able to be done through mathematics. Even mathematics itself cannot be done with mathematics. So let's try to understand more about what is the foundation of mathematics before we move forward.